So this is going to be question number 8, and it's going to be mystery reverse environment diagram. And so it's kind of a tricky question. Essentially, they gave you this entire environment diagram, and you want to fill in the blanks so that you can find a way to actually create this environment diagram. And yeah, so let's get started. And so always a good starting point if you come by a mystery reverse environment diagram is to draw what you have currently. And so one thing to note, I just want to say that I haven't really taken a look at the answer for this problem, so maybe you can see the thought process as I go through this. And so here in the global frame, we have a function called mystery, and it's pointing to a function mystery. Parent is global, and one thing to note is that this corresponds to the mystery in the solution, like the final environment diagram. So that means we're probably good to go. We're not going to do anything with the mystery, and as you can see in these lines, there's really no way to overwrite what mystery is. So we're probably good to go. And then what P is list 2, 3. And then Q is the list containing 4, and then another list. So this might be a little bit confusing. So an element, the second element is another list, and then within that other list, we have P as an element. And since P is a list, it's going to be a pointer, so it's going to look like that. So a pointer to another list because we enclosed it here, and then within that list, it contains P. So that list is going to have a pointer right here. Oh, fuck. Let me move my cam up here. No, why is it stuck? Okay. But yeah, so so that's what it's going to look like right now. And let's make some comparisons on what it should look like. And so first, what we have so far that works out is that we have this 2, 3, and then it matches right there. But the thing to note is that there's another element right there, and it points to a list containing this list right here, which we don't really have. In addition, in the case of the 4, it's pointing to another list rather than P. So actually, it is pointing to another list. So this empty list right here, where its first element is pointing to this P thing, but it also has extra elements like 2 and the 3 right here. So somehow we're gonna have to add that in. And yeah, and let's get started with the actual problem now. And so here we make a call to mystery of blank and blank. And so we see a P and the Q here, we see a P and the Q here. So maybe those correspond to each other, who knows? But yeah, so first line right here, it says P indexed at 1 dot extend of something. And so we have to think P indexed at 1. And so P indexed at 1 dot extend, that means that P of 1 has to be a list, right? Because you can only call extend as a method for lists. And so if we look into what could possibly be P, well, if we pass in P as in the argument, then what's going to happen is that we're going to have P indexed at 1 is 3, and we can't say 3 dot extend. So we can't be passing in P right here. That's not possible. In the case of maybe Q, so now we're guessing Q. So P indexed at 1, which is Q. So they actually switch up stuff for you. If we pass in Q indexed at 1 is going to be this list right here. And from there we can extend elements, right? And the good thing about this is that it turns out we actually do want to add an element to P indexed at 1. So Q indexed at 1 right here. So we do want to add elements right here. As a matter of fact, we wanted to add 2 and 3. So that's probably a good choice. So I'm going to put Q for now right here. But let's consider other things that we could put. Another thing that we could consider is maybe Q indexed at 1, passing that in. so we're passing in that list I just circled. But P, that thing indexed at 1, it would error out because it only has one element, so it's probably not going to be that. And so let's go with Q for now. And then one thing to note is that somehow we're going to want to have to, so this mystery function, we're passing in P for Q. So P actually gets overwritten by whatever Q is. So we have no access to this P list inside of mystery. And one thing to note is that we actually want to be adding these elements 2 and 3 somehow to Q's inner list right here. So because of that, we should probably have access to P and Q, P as well. So we're probably going to also pass in P right there. So essentially Q becomes P, P becomes Q, slightly confusing, but hopefully that makes sense. And so P indexed at 1. So let's say, I'm just gonna like cross this out, pretend that P is Q and Q is P. And then so I'm gonna replace all this P. Actually, it might make it confusing later. So let me undo what I just did. But we're gonna say P indexed at 1. And so that's referring to this right here. And we're gonna extend, and extend is adding like a bunch of elements, right? And so in the case of this, what do we want to add? We wanted to add this list 2 and 3. And then, how fortunate. That's exactly what P is, or like this right here, which is Q. And so we can say P indexed at 1 dot extend of Q. So P indexed at 1 was this list right here. And then so what's going to happen is that we're going to add in the element 2 and the 3. So we're extending Q, and Q was this list 2, 3. And so now we have that, and we got one step closer to our goal. Woohoo! And so yeah, so next up, what do we want to do? Well, the last things that we want to handle is like this block right here. So we already have the list 2, 3. We already have the list 4 in this pointer to like this list containing another list pointing to P, and 2, 3. So last but not least, we want to handle this block right here. How do we handle that block? Well, in the case of this thing right here, select the 2, 3, we're trying to add an element in. And then know how nowhere else we don't really want to add another element. We're good to go for there. And so what we're going to do is that what we're appending to is probably going to be this list right here. So like the 2, 3 list. And then what is that again? That's going to be Q. So remember that P is Q, Q is P. Slightly confusing. But we're going to say Q.append, and we somehow want to append. Let me bring it back. I'm going up to this diagram again. We somehow want to append this list right here. So let's think about what this list could be. So this thing right here, it's a list containing a single element. And this element is pointing to this list containing this list with like something 2, 3. And how do we access that list? Well, it's that list. Okay, so it's this list Q indexed at 1. So its second element is going to be this list right here. So it would be Q indexed at 1. But remember that P is Q, Q is P. So again, slightly confusing. So we're going to take that Q, turn it into a P, and that's where we're going to be appending in. Okay, so let's ignore this 1 colon for now, but imagine right here, we're going to put in P indexed at 1. And then so what do we want to note here? Well, we have this like 1 colon right here. And so we can't exactly put this right here because we're trying to like splice this list instead. And so the thing to know about splicing though is pretty much going to do what we were just trying to do. And so if we splice this list Q right here, so if I had 4, 5, and I said this was like A maybe, and I said A spliced at 1 beyond, it would become the list containing 5. And that's pretty much exactly what we want, right? Because if this had 4 and that other element, and if we splice it from 1 beyond, it should be a list with that list contained within it. So that is exactly what we want, and we want to put P instead, rather than P indexed at 1. So we're going to put P right here. And note that if this 1 colon wasn't here, we could put either P 1 colon or this list right here. Either is fine. And at the very end, we should get the total thing. So in the case of this line, what's happening? I'm writing on the bottom right here. So we're adding this extra element, which is pointing to P spliced at 1 beyond, which is going to be a list pointing to this list down here. And yeah. Okay, that was slightly confusing, but let me make sure I got the right things. Can't really see. Yeah, usually I think now you don't see reverse environment diagrams that often. But it's nice to like have that like thought process in your head, because it's kind of like test taking skills, and to be honest, 6-1 tests are pretty if you have good test taking skills, you can like get through it. So yep, P of 1 that extend Q, Q that append P on beyond, and you pass in Q and P. And yeah, so that's gonna be the solution for question number 8. And let me know if you have any questions. Hope you have a fantastic day.